Dear students, in this particular exercise, we will learn about certain peculiar things for the exercise titled Modeling and Simulation of Packaging Lines, to be precise in multi-grasping. So first let us get into the term what is multi-grasping. So multi-grasping is a task in which a robot with a vacuum suction gripper, it is going to hold multiple components. See, in earlier exercises, what we discussed is we had a robot and it had a same similar suction gripper. What it did is it was able to grasp one particular component, one particular box. And we had two different exercises. The first exercise was where the component was picked from a stationary pallet and it was kept in another stationary place. And the second experiment was it was picked from a dynamic environment and again it was placed on a dynamic environment. So first case dealt with stationary and second case dealt with dynamic. But the same common feature or the similar common feature among both the exercises was only one particular box was lifted. But practically when you get into industrial application, no such scenarios may or may not exist. Why? Because one robot picking up only one particular component is not affordable indeed. It's not economic. So therefore, what is the thing anticipated is one particular robot should be in a position to do picking up or grasping of multi-components. So how to design the same in a visual components, we'll be learning in this particular exercise. So that will be objective number 1. That is how a robot will be able to pick up multiple components, grasping multiple components at one instant. So that is going to be the objective 1. Objective 2 is how to place the same multi-grasped objects inside a particular box, because here the exercise is packaging line. See, obviously, whatever the industrial activity, it is going to be right from design till dispatch. So for a dispatch, there is a different procedure is there. Of course, there is one DFP concept, design for packing concept is also there. So it has to be packed properly so that it goes to the end user or it goes to the another company, maybe sub-assemblies or something like that. So after packing, the box has to be multi-grasped and it has to be positioned inside another box for the case of packing. So how to do it? That will be numbered objective number 2. And objective number 3 is, so far we have did several types of robot programming, but how to call a sub-program inside a main program. You call another program that is called a sub-program. Even the same has been learnt even in a CNC modern manufacturing process, that is in CNC milling or CNC turning we did. And again the same thing is going to be dealt here. How to call a sub-program inside a main program. So these all are the 3 objectives. So with respect to multi-grasping, these all are the 3 objectives. On the generic scale, when you see here, how to do a packaging line. There is a packaging library in visual components. We are going to take up some components in this regard and we are going to do one by one. So this is the clear objective. Now let me get into the packaging concept. So inside the packaging concept, when you see certain things we are going to do. So in this particular packaging line, there are certain new machines which we are going to use and which we have not dealt with it earlier. The first thing is box creator. So box creator is a one particular machine where it is going to have the carton material and it is going to be given one particular shape and we can give the size, whatever the size we wanted to have. Of course, it's going to be a default shape of a cuboid and sizes we can define. That is the length, the breadth and the height that can be given. And second thing is box sealer. Sealer is once, see the first case you create a box. Second case, whatever the components you want to keep inside the box, you may keep it and the top portion and the bottom portion will be sealed properly. And the third case, we are going to use box wrapper. Of course, similar wrapper we used even in our earlier exercises, but this will be a different types of box wrapper. So that's how the first work is going to be. That is, we are going to configure the layout with these elements. Then coming into the conveyor part, here we are going to use certain new conveyors, which we have not used earlier. The first conveyor here is sensor conveyor. What is the sensor conveyor is? See, traditionally we have been using conveyor, and we'll be doing or we'll be fitting an extra sensor part to it. But here it is not so. It is going to be an inbuilt part of the conveyor, where on the conveyor you can see there will be a green line will be there, and that green line acts as a sensor. So the moment you go to the signal, you have the necessary requisite signals in that. That is, in short, we used to do it externally, but here it is an inbuilt one. It is called as sensor conveyor. And coming to the second conveyor, product batcher conveyor. What is this product batcher conveyor? It is clear from the name itself, batcher. That is, it is going to accumulate certain number of components, and those components or those products are going to be called as a batch. For example, you wanted to have a batch of 3 components. You define in the property as 3 components, and that particular conveyor will accept only 3. So that facilitates us to help in order to grasp those components. And in this case, we'll use 9 as the batch size. So 9 as the batch size. So default 9 boxes will be accumulated on the conveyor, and our robot is supposed to pick all the 9 components at one particular stretch. Then sorter conveyor, product sorter conveyor. It is going to sort in one particular activity. See, batcher conveyor means it is going to accumulate the batch. Sorter, how are you going to arrange those boxes? We wanted to have the boxes in an array format. That is, on the x-axis 3 boxes, on the y-axis we wanted to have 3 boxes with no gap in between. So therefore, that's how the sorter conveyor is going to work. It is going to organize everything in the form of an array, and we can define the distance between successive components. So all such things will be dealing in the product sorter conveyor, and arrangement will be dealt under the properties of that particular conveyor. Then shape feeder. Shape feeder means default it is going to give visual components box. So usually we go with the feeder process, then we imbibe the box separately. But when you go for shape feeder, no, obviously it is going to feed to the boxes, visual components boxes, what we dealt earlier. Then generic articulated robot, what we have been using in a routine case. Then parametric suction gripper, yes, we have been using the same. Robot pedestal. The pedestal is nothing but an elevated platform. It's a simple platform on which we are going to mount the robot. And finally, the folding box. So folding box is nothing but the one which is going to be created in the box. Even without that also it is possible to go ahead, because box creator itself will come out with the box. If you want to change, you may change it, or you can just define the sizes. So this is the preamble for this exercise. So now we'll get into the exercise. So after opening visual components, we'll just locate the products. What are the components we just discussed earlier? That is, we'll type as box creator. See, actually it is available in the packaging library under visual components, but let us do it in the first case. So now the first thing is we just brought the box creator. So product number 1 has been brought. So you can see on the back side there are some carton boxes are there, and on the right side it is going to come out. Then the second thing is box sealer. So box sealer is going to paste on the top end. Once the components are positioned, it is going to do the work. Then the third thing is we'll get the box wrapper. So box wrapper is finally it is going to coat everything on the periphery. It is going to have the polythene sheets being wrapped onto it. So the next activities we'll get the conveyors one by one. So the first conveyor what we need is sensor conveyor. So sensor conveyor, see, it is not the regular one, it's a different one. So on the top you can see it is going to have a different green line onto it. So green line, let me take to that search. So here it is there. Sensor conveyor. So sensor conveyor, on the top there is a green line, that means that is the sensor part. So usually we have a conveyor and then we fix to it. Now the next part is we'll have the product batcher conveyor, and beneath it itself we have got product sorter conveyor. Then the another important component is we wanted to have the shape feeder. So now we'll search for the shape feeder. So yes, shape feeder is there. As I told you earlier, shape feeder will default, it will just feed the boxes. Now the next thing is we'll go for the configuration of the layout. Then we'll get into the robots and other things. So now the thing is we just connect the sensor conveyor to the box creator and let us change the length to 3 meters. So now the conveyor length is 3 meter long. Then we'll PNP plug and play the box sealer to it, and adjacent immediately we'll have the box wrapper. So this is the first half of the layout. Then the second half of the layout, what we'll do is we'll just organize parallelly. On the parallel part, we'll just have the another conveyor. That is, we'll have the sorter conveyor. Then we'll just connect the batcher conveyor to it. And finally, we'll have the shape feeder to it. So now this is the rough layout of the configuration what we are going to use. And in between, we'll have a robot, and that robot will pick up from the line 1 to the line 2. Now we'll search for the robot, or we'll directly go to the visual components. Even there also we can go ahead with. So this is a traditional process. We need not to search. So since these all are the other elements or first of its kind, we went. So now we'll get the generic articulated robot from the visual components robot folder. Then we'll get the robot pedestal under robot pedestals. Then finally we'll take the robot tools. So suction cup gripper. So now we'll PNP the suction gripper to the robot. Then position the pedestal on the top view exactly between both these layouts. So in such a way that it is before the first half, that is sensor line. Before the sensor line, we wanted the pedestal to be, and now on the pedestal we can fix the robot. So now the rough layout is ready. And now the next important thing is we'll just move it a little bit so that it is exactly in the half of the both cases. So first layout part is ready. Now the next interesting thing is we'll just go ahead with the further connection between these layouts. So before that, we'll go to the product parameters. So let us have the box size as 200 by 200 by 200 millimeters. So that is the box we wanted to have. So first let us define it. So the moment you have defined, we'll go for the next activity. That is the conveyor width. It is 700 because we wanted to have 3 boxes. 3 by 3 is the thing required. So now we'll go to the properties of the box creator. Under product creator, what we'll do is we'll just change the size. That is under the default, the box length, that is 9 by 9, it is supposed 9 boxes it is supposed to have, 3 by 3. So 610, 10 mm is gap. So 200 into 3, 600, and on the height 210. So therefore 610 by 610 by 210. So now the rough layout is ready. The sizes have been defined. So now the next part is we'll go for the signal. Before that we'll simulate it. So you can see the batcher is reorienting the box size. So it is not permitting to pass in the single line. And on the second line you can see a box is coming. So in that particular box we wanted to have 3 by 3 boxes, visual components boxes to be positioned. And here the default settings have permitted only 3 components in the batch. So now we'll see one by one how to do it. So first foremost is we wanted to have a batch size of 9. So select the batch conveyor. Under the properties, batch size is 9. So now what will happen is when you simulate it, the batch conveyor will agree 9 components. Earlier it just agreed 3 because the batch size was a default 3. So now you can see it has arranged, it is agreeing 9 components. So first half is okay, but it is not proper. It is in an haphazard case. We wanted to have 3 by 3 matrix, right? So with the batcher conveyor, that is the setting. Of course, there is one more signal setting that I'll tell you later. So now we'll go for the sorter conveyor, go to positions. Second, index by note. When you open the editor, you can see there is a size called as -172. Here our box size is 200. So plus side you give 200 and minus side you give us 200 and close it. That is the distance among the boxes. So now let us run the simulation. Since the box size is 200, we gave 200. So based on the problem statement, we can go ahead. So now you can see the boxes have been literally arranged into 3 by 3 matrix. So now we wanted the robot to lift this particular 9 boxes onto position onto the second thing. So that's how the packaging library works. So now what we'll do is we'll change the number of suction grips. So we'll have the suction grips as 3 by 3 and the distance in between is the total thing. So therefore 200 in between, the distance between two successive cups in both this axis. So 200 by 200. So now we have got 9 boxes, we have got 9 cups. So this 9 cups are supposed to pick the component up. So first we'll go for signal, select the robot, and we are getting the signal dialog box. So pay attention. From the input, start from the robot input, take it to the sensor conveyor. Then output of the sensor conveyor to the stop. Then robot. Again start from the robot, come to the boolean signal of the batcher input, and output is similarly to start and stop. So always start from the robot. So now these all are the things. But the thing is, we wanted to rename because input is only 1. So we wanted to rename. So port number 1, you change it to 50. See, 50 is random. There is no particular rule, just random. So now you can see input is only 1. That is, both have been given in the same connection. So input should be 1, output should be 1. So that's how we are renaming. So signals work is over. Now the next thing is, we'll go for the program, robot program. Select the robot program. So the first work is, you are going to set out the signal. So first 0 port is the second one. So if it is true, set out. If that is also false, the layout should stop. So input 0 should be true initially. It is stopping. So set out should be false. That is stop the layout. That is what we have told it. Now we'll call under this scenario, we'll go for the another thing. Once the box has stopped, you wanted to have a pick program. So we have created a new program called pick. So under the pick program, now the second sensor, the port is 50. Once the 50 is true, and give wait trigger also, because it should give a signal halt. So this is the rough program what we are doing. So again we'll check. So first I0 is true, so set out 0 as false, then go for the pick program. So now we are supposed to define the call sequence, that is the program. So there is a pick program. What we'll do is, we'll change it. And before that, we know the process. The Gimbo has to be changed to the TCP of the gripper and tilted to the ground. This we did earlier, that is in exercise 7. Change the value to 0, and we knew the next step, we need to save the state under the setting of the simulation. So now it is ready for the pick and place activity. So first, this is the home position. Let us kick the P2P point. Then from that, bring the Gimbo to the center of the top of the 9 boxes. So position it and define the another point. So let this be LTP point, linear point. Then after grasping, it is supposed to go above the height of the successive carton box. Then only it can be positioned inside. So once this is over, we wanted to do the grasping action. So what we'll do is set the port out to be true. This we did earlier. Let us give the port number as 1 because 0 and 50 has been specified. So now go to the properties under the action configuration. Port number 1, when it is true, means it is supposed to perform grasp action. So that we'll define. So now we'll see the working of the activity, whatever we did so. Now it is not working. Why? Because we have not called the pick program. So now in the main program, we'll call the call sequence pick program. See, since only one program is there, default it is coming. That halt step will delete it up. So now we'll see the activity. The 9 batches are getting ready. Now the robot comes and it is not picking. Why? Because we have modified the statement. So that's where it is not happening. Again, we'll do the same work. So before that, let us check whether it is properly adhering. Yes, it is there. There is no gap. It is touching the surface. So again, we will define the things and change the gripper TCP that has not been changed. So now we'll see it. See, this is how the error rectification has to be done. In first shot itself, we may not get the expected result. So we need to fine tune the work. So now it is picking. But the problem is only one box is getting picked up. We need to have multi-grasping, but that is not happening. We'll now rectify it. Select the robot. Go to home. Don't do in program. Select the robot. Now go to the signal actions. So there you can see there is one thing called as multi-grasp. The fourth option from the top. Check it out. So now we are asking the robot to do the multi-grasping activity. Now when you see again it will not do or we cannot get the expected results. So we'll see how to troubleshoot it. No, still only one box is getting picked up. Why? Because the volume of multi-grasp picking is not been specified. So again go to component property. So bottom you can see grasp. What is the detection volume? So here the volume is 50 by 50. Now let us give randomly 200 by 200. But actually it is supposed to be little bit 300 by 300, X300 and Y300. So now marginally it will pick up. Marginally it will pick up. So now we'll see. Yes, marginally it has picked up. The total volume is 600 by 600. That is X plus 300, X minus 300. Similarly, Y plus 300, Y minus 300. But we'll define on only one side. So 300 by 300 we'll specify. And now all the 9 boxes will be getting picked up. So this is how the multi-grasping is getting differentiated from just picking up of a singular component. So plural component, multi-grasping has to be enabled. Then volume has to be enabled. Now, the place sequence, the component has been picked. It has to be positioned inside the box. So we'll go for another program. So now the first point on the top of the box, but these 9 boxes should not hamper, it should not affect. So position somewhere on top, approximately middle in all the 3 axes. Then let us define as the home position for that particular place activity. Now bottom we'll go for align. Select the bottom middle surface of the box, then tilt on top of the box, it has to be positioned. So we are getting the snap properties, just position it. So this is the second activity. So after positioning, we wanted to release those components. So set port number 1 to be false. That is release those components. Now after releasing, the robot has to come outside the box. So lift sufficiently and again specify a point. So now we'll go to the main program. We'll call the second subprogram. So now default it is taking the pick. We'll change on the right side properties to place program. So now it has placed. So since the simulation speed was high, it took place within a short while. So in the main program, we are setting out 2 things. And here again, one more thing, that is set the program false. That is the looping has to occur. And again, we'll go for the looping activity. So now 9 components are coming. The batch is picked up. It is positioned. But the problem here is they are getting disoriented. The reason for disorientation is the gravity. So we'll see port number 1. Earlier we specified the volume. Now on the bottom you can see release gravitational. The distance is just 0.2, not 25 mm, just 0.2. So that it gets inside the box. But still it will not give the or it will not yield the expected results. We'll see why. Where the components are positioned is, it is positioning on the conveyor, not into the box. So how to do is, select the robot, not the conveyor and everything. Just select the robot. Where the robot is supposed to position is, it is supposed to position on the inside the box, not on the conveyor, because there is this minimum thickness of the box. So what we'll do is, we'll just go to home, select the box. So under signal actions, you can see exclude releasing to. So there are 2 options. You can select from this list or you can select from on the clicking the yellow box, you can select the component directly from the layout. So we'll just go for the plus. So not on the sensor conveyor, select. It is not included into it. It has to be positioned on the box. So now things will be right. So now 9 boxes are getting ready. Now it is getting positioned properly. So this is how you are supposed to fine tune the results. So now you can see it is getting sealed up. In the next stage, the boxes are getting wrapped up. You can see some small texture difference on the box. Yes, the polythene cover, it is getting picked up. So now the process is not getting looped up. The process is not getting looped up. Time and again it is supposed to occur. Why it is not occurring is, we know it is supposed to be inside the loop, but now the program is not inside the loop. So now we'll rectify the mistake. So now select the robot, go to the program. So under the main program, so all these things, that is first statement, if it is true, it has to go ahead. So we'll have a small delay of 5 seconds. Copy down all the statements, go to while loop, position it onto the first and copy down the rest, all these things, Control X and go to the empty part, empty, and paste it up. So no empty, everything, if when all this first statement is true, let it go on the loop. So that is the thing necessary. So now the looping has to occur. So get into the results, identify and troubleshoot the thing, whatever is necessary. So again it is not going, and the problem is with the port number 50. So nowhere we discussed about port number 50. So port number 50 has to be again enabled. Port number 0 is okay. So now we'll go for the main program. The pick program, we'll just go for not the 0, it is 50. So if it is 50, then that signal is getting triggered, then it can go. But still, the results will not be to the expected. The reason is the settings of the batcher conveyor is again, it is supposed to be modified. Yes. Now the thing is okay. Now everything is okay. But you can see a trace line for the robot is occurring. A trace line for the robot. So the trace line for the robot, the reason is port number 50 of the robot, it means that there is a trace line. So select the robot, go to signal actions for the 50th port, 50 port, go to the trace, first empty, nothing. So go for the blank thing and now you can see there is no trace line. So even if there is trace line, it's not going to be a big harm. So this is how we do the activity. So then the next procedure is save the file. So convert the file to PDF and then to the drawing. So thank you.